Hello, welcome to our learning activity on Math Packs for Senior High School Pre-Calculus, Quarter 1, Week 4A. The objective of this learning activity sheet is the learner defines a hyperbola. Let's go over with the generalizations. A hyperbola is the set of all points xy in a plane such that the difference of its distances from two fixed points called the foci, or if it's singular, it's the focus, is a positive constant. The line containing the two foci of the hyperbola is called the focal axis. The center of the hyperbola is on the focal axis. It is midway between the two foci. The focal axis intersects the hyperbola at two different points called vertices. The line segment connecting the two vertices is called the transverse axis. The line segment passing through the center and is perpendicular to the transverse axis is called the conjugate axis, wherein the endpoints of this conjugate axis are called the co-vertices. The transverse axis and the conjugate axis bisect each other at the center of the hyperbola. Every hyperbola has two axes of symmetry, and these two asymptotes that pass through its center. So these two asymptotes is what we call oblique asymptotes. Figure 1 below shows the different parts of the hyperbola. So we have here on this side of the hyperbola, we have the two vertices, and this point here, and F1, point F1, F2 are the what we call the foci. Focus F1, then focus F2. Vertex V1 and vertex V2. Now, this line here is the x-axis and the y-axis. Now, in this particular hyperbola, we have this A units from the center going to the vertex. It's A units. And from the center going to F1 is what we call C units. In this case, we have it here, the C units. And from the center again, going up, or going down, we have from the center going up, it's B units, the same distance from the center going down, and the endpoints of these two are what we call the co-vertex. So we have here co-vertex 1 and co-vertex 2, or either way. The line or the axis that contains the co-vertices are what we call the conjugate axis. In this case, we have here the arrow, and it's a conjugate axis. And the axis that contains the center and the two vertices and of course the two foci is what we call the transverse axis. Okay? And we have these two broken lines. As you can see, these are what we call the oblique asymptote. The asymptotes passes through the center of the hyperbola. So this is the hyperbola. Let me go over this one. The distance from the center to each vertex is A units. Hence, the length of the transverse axis is what we call 2A. The distance from the center to each co-vertex is B units. Hence, the length of the conjugate axis is 2B. The distance from the center to each focus is C units, where we have C squared equals A squared plus B squared. For any point on the hyperbola, the absolute value of the difference of its distances from the two foci is 2A. So meaning here, let's try to demonstrate. Say we have this point P, any point here, and let's connect this point P to focus F1. and then another point at the same point xy or p here, and this distance. If we take the difference of the distance p f2 and the distance p sub f1, it will be equal to 2a. That is the meaning of the sentence here. Let's go over the example. But before that, let's have this again. The hyperbola with center at the origin has the standard equation. We have x squared all over a squared minus y squared all over b squared equals 1. If the transverse axis of the hyperbola is on the x-axis. Take note, the x part here is before, or it's in the minuend. The y part is the subtrahend. So if it's the case that the minuend contains x squared, then the transverse axis is the x-axis. And this is it. This is an example of a hyperbola. Figure 2 reflects this equation. X squared all over a squared minus y squared all over b squared equals 1. Another case is when the minuend contains y squared. In this case, the focus and the two vertices are along the y-axis in the parabola with center at the origin. In this case, we have y squared over a squared minus x squared over b squared equals 1. And the transverse axis here is the y-axis. The asymptotes and the length of the asymptotes. Let's discuss this. The asymptotes of the hyperbola are the extended auxiliary triangle whose sides are parallel and perpendicular to the transverse axis, and the lengths are 2a and 2b. So this is it. This length is 2a and this length is 2b. Now it says here, if the transverse axis is on the x-axis, in this case, this is what we call the transverse axis on the x-axis, the equations of the asymptotes are given y equals b over a x. This one, it's a positive line. Okay. And another asymptotes is negative. This broken line, if we extend that, it's negative b over a x. Now, if in case the transverse axis is on the y-axis, as in figure 3, then the equations of the asymptotes are given to be y equals a over b x. This is the standing line, the rising line here, extending it. And another one is y equals negative a over b x. Let's go over with the examples. Example 1 first. Determine the coordinates of the foci, vertices, co-vertices, and the asymptotes of the hyperbola with the given equation x squared over 16 minus y squared over 9 equals 1. In this case, the minuend, this is the minuend, the subtraction symbol, this is the subtrahend, and of course the difference. This is the minuend. So meaning the minuend contains x, so that means that the transverse axis of the hyperbola is on the x-axis. In this case, whatever is the denominator of the x squared that contains the transverse axis, then that is the a. So in this case, we set a equals 16. And of course, this is b squared equals 9. And squaring square root, taking the square root of a squared is 4 and b is 3. And we have to get c, so that we have to find all these coordinates that is asked in this given problem. Solving for c, recall that c squared equals a squared plus b squared, and c is equal to the square root of this a squared plus b squared. Then we have c equals the square root of a squared 16 plus b squared 9, that's the square root of 25, c equals 5. Since the transverse axis is the x-axis, so we expect that the focus or the foci is, we're given c equals 5, so the foci is negative 5, 0, and 5, 0. Then the vertices is the coordinates are, since a is 4, so we have negative 4, 0, and 4, 0. And of course, the co-vertices, we have b is 3, so it's where the co-vertices lies. So coordinates of the co-vertices are 0, negative 3, and 0, 3. You have to remember this. And for the asymptotes, it says here the asymptote, since the transverse axis is the x-axis, then we have negative b over ax and y equals b over ax. In this case, our b is 3 and a is 4. So plugging in the values by substitution, we have this asymptotes. Before we proceed on example 2, let me give you this graph. I have searched this in the book. Here is the book, so you can browse it over. This is an additional knowledge on the conics, what we call hyperbola. So the properties of a hyperbola with center at the origin are summarized in this table. So we have this equation with the minuend that contains x squared. Then we have x squared minus over a squared minus y squared all over b squared equals 1. Of course, it says here the transverse axis coincides with the x-axis. Center at the origin, foci could be plus or minus c, 0. Coordinates of vertices, plus or minus a, 0. And the asymptotes, y equals plus or minus b over a, x. In the case where we have this equation y squared over a squared minus x squared over b squared, the minuend contains the y squared, then the transverse axis coincides with the y-axis. Center at the origin, the coordinates of the foci, 0 plus or minus c, vertices, 0 plus or minus a, and the asymptotes are y, the equations of the asymptotes, y equals plus or minus a over b, x. Remember this, b squared equals c squared minus a squared, where c is greater than 0. Here is the following graph. And we have here a remark. For the hyperbola, there are no requirements involving the relative sizes of a and b. Meaning, it could be that a is greater than b or b is greater than a. Moving on to the module or the learning activity sheet. I will just browse this example 2. And we proceed with the exercises. There are 2 numbers to solve here. And I will give you the solution in a little while. For the directions, give the coordinates of the foci, the vertices, co-vertices, and the equations of the asymptotes of the hyperbola with the given equation. Let's do number 1. Y squared over 36 minus x squared over 64 equals 1. For the solution, based on the given equation, y squared or the minuend contains y squared, so the y-axis is what we call the transverse axis of the hyperbola. Solving for a given a squared equals 36, so we found a equals 6. Then b squared is 64, square root of 64 is 8. Then c squared equals the sum of a squared and b squared. In this case, we have c squared equals 100, c square root of 100 is 10. So we have now the values of a, b, and c. And we are now ready to plug in the required coordinates of the foci, the vertices, and the co-vertex. See? So recall, coordinates of the hyperbola with y-axis as its transverse axis, foci, coordinates are 0, plus or minus c. So in this case, our c is 10. So we have 0, negative 10, and 0, 10. For the vertices, we have 0, plus or minus a. So a is 6. So vertices now is 0, negative 6, and 0, 6. Co-vertices, we have b. So we have the plus minus b, 0 as coordinates. Value of b here is 8. So we have plus or minus 8 and 0. For the equation of oblique asymptotes, we have, it says here, if it's in y is the axis of, the y-axis is the transverse axis, so we have y equals plus or minus a over bx. Plugging in the values, our a is 6 and b is 8, so we have plus or minus 6 over 8x, or reducing 6/8, that becomes 3/4. So we have two equations here of the asymptotes. We have y equals 3/4 x, and the other one is y equals negative 3/4 x. Moving on with this, another exercise number 2. Still, we have to get the foci, coordinates of this foci, vertices and co-vertices, and of course the asymptotes equations. So we have the hyperbola with the given equation x squared over 25 minus y squared over 4 equals 1. As you can see, the transverse axis is the x-axis. And a squared, wherever is the transverse axis, we have there the a squared. The denominator is a squared. So in this case, it's 25. And a becomes 5. Then b squared is 4. B is 2. Then to calculate c, we have square root of 29. Moving on, recalling the values. Coordinates of the hyperbola with x-axis as its transverse axis. We have for the foci coordinates, we have plus or minus c, 0. Then vertices, plus or minus a, 0. And co-vertices, 0, plus or minus b. And for the equation of the asymptotes, we have y equals plus or minus b over a x. Let's see. Recalling the values, substitution. By substitution, we have foci, c plus minus c, 0. So we have c is square root of 29. So we have negative 29, 0, and 29, 0. Done. Vertices, we have a plus or minus a, 0. So we have negative 5, 0, and 5, 0. For the co-vertices, we have b is 2. So we have 0, negative 2, and 0, 2, positive. Then for the asymptotes, plus or minus b. That's 2 and over a fifth. So asymptotes, y equals plus or minus 2/5 x. This concludes our learning activity in this video. And this is again Teacher Marichu saying stay happy, healthy, and safe. Thank you and God bless.